Domain of rational functions. When we talk about the domain in general, we're talking about all the values that x can be. If we're talking about y equals f of x, right? Y is the range, domain is the x values. And the domain is all the things, again, that x can be. Well, when you have a rational function, that means we have a fraction, and we have a denominator. That's the bottom. The fancy word for bottom is denominator. And if we have x's in the bottom or denominator, then it's possible that the denominator could equal 0. So anything that makes the bottom or the denominator 0, any x value would not be in the domain, because if you recall, if we have something over 0, like if we have some number 7 over 0, we call that undefined, if you remember. Okay, since it's not defined, then you can't have any domain value there. So if x makes the denominator 0, the bottom 0, then it's not in the domain. So the domain of a rational function is the set of all real numbers except the x values that make the denominator 0. All right? So everything is good except the things that make the denominator 0. So to find the domain, set the denominator. Now look, this is a guessed thing here. Not equal. All right, I set my denominators not equal almost exclusively, okay, because I'm reminding myself each time that it cannot be 0. So set the denominator not equal to 0 and solve it just like it were equal. And then again, I put not equal to remind myself, hey, I'm excluding, I'm restricting these values. So the x values that you find are left out of the domain, are restricted, they're excluded because they make the denominator equal to 0. So let's find the domain, and I put it in interval notation here. So that's kind of the big dog, so to speak. Interval notation is the way that you write many things, and so let's go through this and find some domain here for these rational functions and put the answers in interval notation. Now, one thing as we begin this, if you solve the denominator equal to 0, and you have 3 numbers that you find that make the bottom or denominator equal to 0, you will have 4 intervals if all you have is a rational function. Now, if you start mixing rationals with radicals and other things that restrict domain, then okay, maybe that's the case. But if we're the 2 major ones, by the way, that we talk about are this and radicals. We won't talk about radicals in this video, all right? We'll just talk about rationals. But if all you have is a rational function and it's a polynomial over polynomial, then anything that makes the bottom 0, if you have 3 numbers that make the denominator 0, you will have 4 intervals in your answer. If you have 7 numbers that make the denominator 0, you'll have 8 intervals. If you have 1 number that makes the denominator 0, you'll have 2 intervals. It's always 1 more interval than numbers that you leave out of the domain. So let's look at this first one. F of x equals 7x over x minus 8. When we're talking about the domain of something that is a fraction that has a top and a bottom, that has x's in the denominator right here, we don't care. This up here, this 7x, that might as well be Mickey Mouse, okay, or a Mack truck, or a baseball, all right? Or who knows, it could be whatever. Doesn't matter. So all we care about, so for the domain of f, all right, I like to call it a process step, okay? My process step is denominator not equal to 0. That's what we talk about. Set the denominator not equal to 0. That's my process step. So anytime I need to identify fraction, x is in the denominator, the bottom, I'm finding domain, that's my setup, my recognition piece, I always then say, okay, the denominator cannot be 0. And then from that point, I have to use all the ways I know to solve things from algebra in my entire math life. This is what we call linear first power. This is easy as far as solving things go, right? We simply add 8 to both sides and we're done. If that was x squared or x cubed or something like that, this would become more complicated. All right, so then x cannot equal 8. So I'm leaving out how many numbers? 1. The one number I'm leaving out is 8. Poor 8. We hurt its feelings this time, okay? No, 8 doesn't have feelings, all right? So we're leaving 8 out. If we leave one number out, I just told you, if we leave one number out, we have 2 intervals. So we have everything less than 8 and everything greater than 8. But we cannot have 8. In fact, we have every number in the whole world, every real number ever, real numbers I should say. We have every real number ever except the number 8. So how on earth do I do this? Well, it's sort of like taking the number line and taking 8 and just chopping 8 out of it. So you got everything over here and everything over here, this way and this way. Okay? So how on earth do we write that? Well, we have to go from negative infinity up to the number 8, and then we go from 8 up to infinity, right? That takes every number in the world except 8. But how do we show that? If you remember, infinity and negative infinity always get parentheses because parentheses, remember, means we do not include it. Infinity and negative infinity are directions. They are not numbers. So you can never include infinity. Infinity and negative infinity will always get parentheses in interval notation. So if you recall, the thing that includes the number is a bracket, right? So here, would we include 8? No, because we said x cannot equal 8. So then 8 is also going to get parentheses. And then we use this union. This is a U. This is not the letter U. We don't have the tail or the kickstand there, okay? So we just have down and back up. It's a union, all right? The union is not the letter U. It is a symbol, all right? So then negative infinity to 8, union 8 to infinity. I also like to talk about we chain link our intervals together with the numbers that are restricted. So 8 is our only restricted value. We chain link our intervals together with 8. If we go up to 8, we pick back up at 8. We don't skip from 8 to some other number. All right? So this is the domain of f right here, the domain of f. Negative infinity to 8, union 8 to infinity with parentheses for all of them. So let's look at the one beside it here. Let's look at the next one. All right? So f of x is 2x squared over, and we have this already factored, x minus 2 and x plus 6. Remember, to be factored, all my pluses and minuses are in parentheses, and all my powers right here are not bigger than 1. If they're bigger than 1, it doesn't guarantee it will factor, but I try to factor it further. So here, this one is factored. I also have no GCS in either parenthesis. So this is factored. So then what I do, again, my process step for my domain of f here is to take my denominator, x minus 2 times x plus 6, and do what? Say it's not equal to 0. That's my process step. Always my process step. And I recognized it because I have a fraction, and I have x's in the denominator, and I'm looking for the domain. All right? So what I found is we math teachers, we do a good job of teaching you steps, and everybody knows steps, but people don't know when to do what step. And so often in my videos you will hear me reference recognizing what to do. So here we recognize domain, fraction, x's in the bottom or denominator. This is what I do. All right? Denominator not equal to 0. So normally, this would be x squared, by the way. If I FOIL this out, if I multiply it out, binomial times binomial, I would end up with x squared. But how do you solve x squared, a quadratic? You factor it, and then set each factor equal to 0. Well, guess what? It's already factored. So then I can simply go to set each factor equal to 0. I don't need to go to any other. And someone told me I need to put nor here, not or. So x minus 2 cannot be 0, nor x plus 6 cannot equal 0. All right? So then I'm going to add 2 to both sides. So x cannot equal 2. And over here we're going to subtract 6. And so x cannot be negative 6. So here I'm leaving out how many numbers? How many numbers are excluded or restricted from my domain? That's right, 2 numbers. And those 2 numbers are 2 and negative 6. So I have to be careful. I can't just go from negative infinity up to 2. I've got to go from negative infinity to the smallest number. Okay? And the smallest number in this case that's being restricted is negative 6. The other thing is I left out 2 numbers. I have how many intervals? Correct, 3. It's always one more. So I know I have 3 intervals. What are my 3 intervals for my domain of f? I go from negative infinity to the smaller of the 2 numbers. The smaller number is negative 6. Again, negative infinity always gets a what? Parenthesis. And when you're dealing with domain of rationals and all you have is rational, polynomial or polynomial, then you're only going to have parentheses in your domain. You won't use a bracket. All right? So you're not going to include negative 6, and then we use our little union. And if you recall, I said we chain link these together. The temptation is to come over here and put 2. But we don't skip from negative 6 to 2. You're leaving out way too many numbers. We want to leave out just the 2 numbers. So we pick back up at what? Negative 6, and then we go up to what number? The next biggest number. In this case, the only other number is 2. And then we close our parentheses, and I didn't leave myself enough space. So union, and then we pick back up at 2, and we go out to infinity with a parenthesis. Okay, and so there's our domain. Negative infinity to negative 6, that's our first interval. Union, we're going to chain link the negative 6 together with the union. And then negative 6 to 2, that's our next interval. That's all the numbers between negative 6 and 2. Then we're going to chain link with another union, the 2's together. And we go from 2 to infinity. So we got every real number ever that ever existed, real numbers, except negative 6 and 2. And that's exactly what we wanted here for our domain of this rational function. All right, so let's go through this and let's find some more domains. Again, I didn't talk about it on the second one, but it really doesn't matter. You can look at this and go, oh my gosh, that's so hard to factor. It doesn't matter. Not for domain. That might as well be Mickey Mouse went to town or a monkey hanging from a tree, okay? It doesn't matter. It could be my dog in the backyard. It doesn't matter. All that matters for domain is this. That's it. So the domain of f, again, I'm recognizing it. I'm recognizing here. And my recognition piece is, again, domain. I have a fraction with x's in the denominator. That means I take the denominator and set it not equal to 0. Nothing else matters for domain. This is it in this scenario. So here, this is not factored. This is not factored. So that means to solve this, I'm going to try to factor it. Now remember, with quadratics, it may be quadratic formula, it may be complete the square, it may be square root property, but here we're going to factor. The factoring should work here. And this is what I call list method, all right, named by one of my students not too long ago. All right, so again, it's 3 terms. There's a 1 in the front, so I read it as the factors of 10 that add to give me 7. So my factors of 10 are 1 and 10 and 2 and 5, and the ones that add to give me 7 are 2 and 5. And then I don't worry about the negative 7. I'm coming back to that. So then they're both negative, okay? The plus sign says both, and then it's the first sign, so both negative. And that factors that properly. It works every time. Go watch the list method video if you need to need some help with factoring, all right? Because it will help you with this kind of factoring for sure. All right, so then here we have x minus 2 cannot be 0, nor x minus 5 cannot be 0. And then we solve each one of these. We're going to add 2. So x cannot be 2. We're going to add 5 to both sides. And again, I know a lot of people skip these steps, but when you miss it, I say, I told you so. So, I mean, it takes you, a few extra seconds. Show the step so you don't get it wrong, right? So then here I'm leaving out what? 2 numbers. 2 numbers. Leave out 2 numbers. I should get 3 intervals. I start at negative infinity for my domain, and I'm going up to the smaller of the 2 numbers. And 2 is the smaller of the 2 numbers here. So then I parentheses around both sides, right? I'm not including the 2, and I never include negative infinity. I'm going to union with and chain link these 2's together. So another 2 with parentheses. So again, what that does is I'm going less than 2, right? I'm coming all the way up to 2, and I'm getting as close to 2 as I can get without touching 2. And this is where it kind of math can blow our minds. What's the closest number to 2 less than 2? Well, if you say 1, I say, well, what about 1.5? And you say, what about 1 and 0.75? And I say, what about 1.8? And you say, what about 1.9? And I say, what about 1.99? And you say 1.999. And if we're competitive, we can play this game forever. Okay? So there is no closest number. That's why we developed the parentheses and brackets. All right, so we go all the way up to 2 with the parentheses. We pick back up at 2 with the parentheses. We got every number squeezing 2 on both sides, but we don't have the number 2, which is exactly what we wanted. We go from 2 up to the number 5 with parentheses. We chain link it with the union, back to 5 with the parenthesis, and we go out to infinity, which always gets a parenthesis. So that takes care of our domain, takes care of leaving out our 2 numbers. We have 3 intervals. All right, so then let's work on this problem here. F of x equals 2x plus 7 over x cubed minus 4x. And again, it doesn't matter what this up here doesn't matter. I identified this as domain fraction with x's in the bottom or denominator. Therefore, the domain of f, the way I find it, always, always, always is take the denominator and say that bad boy can't be 0. All right? So here, this got to be factored. So do I have a GCF? I do. So let's take it out. We get x squared minus 4 equals 0. And then I say, okay, this 2 says the power is bigger than 1. Try to keep factoring. So this is difference of squares, so x plus 2, x minus 2, and don't forget the x's out front. And so now I have this thing factored, and all three of these, x cannot be 0, nor x plus 2 cannot be 0, nor x, almost ran out of room here, minus 2 cannot be 0. So x cannot be 0 is already solved, and then negative 2 here, subtract 2 from both sides, so x can't be negative 2, and over here add 2 to both sides, and we end up with x cannot be 2. So we have how many numbers left out of my domain this time? 3. So that means how many intervals am I going to have? That's right, 4 intervals. 4 intervals, so I go from negative infinity to the smallest of my numbers that I'm leaving out. Now again, parentheses on negative infinity. The smallest of my 3 numbers, 0, negative 2, and 2. There's only one negative number. It's the smallest, negative 2. Again, parentheses because you don't want to include that number. All right? You're being exclusive here. Union, and then parentheses, negative 2, up to the next biggest number. The next biggest number after negative 2 is 0. And then again, we don't want to include 0, so we exclude it. Sorry, 0. Okay? And then again, we chain link it together with the union, back to 0. Always chain link the same numbers together here. And then 0 up to the next biggest number, which is 2. It's the only one I have left. And then again, parentheses, I want to exclude 2. And then chain link it together again with the union. And then now I don't have any other numbers to leave out, so I go all the way from 2 up to infinity. And that is my domain. I have 4 intervals. I left out 3 numbers there. All right? 4 intervals, left out 3 numbers there. All right, so this was domain of rational functions. Hope that helped you out there.